In the southeast, where there's no natural deposit of good aggregate, the existing road network provides a mineral resource which should be reused. We've been using in-situ recycling for the last 20 years, so it's not a new process from our perspective. We've been able to encourage other authorities to use it based on our experience.
To begin the process, material samples are taken from the existing carriageway. This identifies particle size distribution, moisture content, and the general makeup of the material to be recycled. In many cases throughout the UK, some older road construction can sometimes reveal the use of hazardous coal tar layers within the existing structure. SPL's process of re-engineering this material as a hydraulically bound structural layer negates the need for expensive decontamination treatments or disposal at landfill.
The in-situ recycling process involves removal of the bound layers of the surface and then pulverisation of the foundation layers. The pulverisation allows you then to remix with a hydraulic binder.
This process of encapsulation and reuse provides the client and stakeholder with a sustainable and cost-effective solution to this widespread issue of tar-contaminated materials. Through this reconstruction, all of the elements and raw materials that were originally on site, SPL's in-situ recycling is not only minimising waste, but is also greatly reducing traffic movements usually associated with road reconstruction.
The advantage of using blended cement products as part of the hydraulic binder, in particular a 70% PFA, 30% OPC mix, means that the hydration reaction is much slower. So even when it's protected with the asphalt layer on top, the hydraulic bound layer that's produced by the in-situ recycling process continues to gain in stiffness for many months afterwards. This concept of low strength, high stiffness is very important in designing pavements. The benefits of in-situ recycling are that you can improve the foundation on a network which is poorly constructed, anywhere where the road is a bit thin, a bit weak, or has in fact failed. And you can avoid tar-contaminated arisings going to landfill because they can be treated in situ and re-engineered.
The process can be used on virtually any type of road in a network, subject to appropriate design, and is suitable both to rural and residential environments. The speed of the recycling process and a consequential reduction in the construction program can reduce works on site by as much as 4 times over traditional reconstruction, thereby greatly reducing the disruption to residents in urban areas. And whilst operating under a road closure, the access to premises and property within the site can be marshalled and managed safely, since there are no excavations or materials stockpiled.
In Norfolk, we've got 10,000 kilometres of network, 9,000 kilometres of which have never been formally constructed. We have a latent demand for improved foundation out there. In-situ recycling offers this chance through conventional maintenance budgets. The other advantage is you can do the construction process much quicker.
We're working on the A39 as a consequence of the existing condition of the pavement, which is at a point where it requires intervention. We engage with the market through our framework contract to ask each of the suppliers to come up with a 20-year design solution that could be undertaken with a minimal disruption to the travelling public. Traditionally, each highway authority runs its core services through a TMC, a term maintenance contract, and that is usually through a single service provider. What a framework contract enables you to do is have greater flexibility over roles and responsibilities on each piece of work. In recognition of the need for expertise that we don't currently hold within the County Council, we put the role of principal designer and the Tier 1 contractor upon the supplier. And what that's done is it's enabled SPL to come forward and provide us with the knowledge and their expertise for our consideration. SPL fulfil a number of roles in this piece of work. So what they've had to do is engage with the likes of Norfolk Lab to undertake the design and the pavement design and supply that to the client for authorisation. But equally, they've then had to go on and engage with all the different supply chain. The timing of the work is absolutely critical and there's a key factor in our considerations as to how the work would be awarded. The works are undertaken at night to essentially minimise disruption, and that's why we've got the dynamic traffic management in place during the working day.
In order for a client to have confidence in the construction process, they can set a minimum in situ stiffness level to be tested at construction. This can be based on any of the levels in the Highways Agency specification IAN 73. A typical Type 1 unbound layer will give you a surface modulus of between 50 and 100 megapascals. A typical hydraulic bound layer will give you anywhere between 200 and 600. I've not known a single contract where we've not achieved what we set out to achieve, following the right procedures on site.
Somerset County Council is the highway authority. They have a responsibility to look at innovative types of work. There is a national DFT initiative called HMEP, and what that does is it encourages the highway authorities to use different tools for their surfacing treatments. And we recognise that in Somerset we are quite limited to those tools, so we use traditional methods such as surface dressing and resurfacing. Supporting the use of in situ recycling, what we're doing is we're widening our toolkit, and we can then evidence that, and on the back of that evidence we can hopefully secure greater funding from central government, so it's a win-win.
In summary, following early engagements with the client and stakeholder, site surveys and testing take place to ensure the appropriate design solution and approach is specified for each carriageway. A strategy can then be developed around a programme of work to ensure efficiencies and optimal management of materials, tar-bound or otherwise. Quality plans will be developed for each site to ensure the successful delivery of the reconstruction. Further testing is carried out during the recycling process on site, in order to ensure accurate delivery of the approved design. Following SPL's inspection process on completion of the works, site records will be issued to the client.